Welcome back, physicists. Today we're going to talk about position, distance, and displacement. So to start off, let's focus in on position. Okay. So the position of an object, okay, is just where it's located. And we usually attach with it that at a particular time. Because usually an object's position is going to change as time goes by. So we'll start off by starting with a number line, okay? And on that number line, let's go ahead and label some points. You'll notice that my number line goes in the positive direction, it goes in the negative direction, and I will mark off some locations. So perhaps at t equals 0 seconds, the object is at 1, and at t equals 1 second, the object is at 3. Let's do that at t equals 2. It's back at 1. And let's say that at t equals 3 seconds, it's at negative 3. So one way I could write that is I could write this as like an ordered pair. I could say that the x when t equals 0, that gives me 1 meter. And the x when t equals 1 second, that is 3 meters. X when t equals 2 seconds, that is 1 meter. And x when t equals 3 seconds, that is negative 3 meters. Of course, even if I change the number line, let's say I went and renumbered. So instead, now I have 0, 1, 2, 3, 4, 5, 6, 7, and 8. Yeah, these numbers would be different, but that doesn't actually change where any of the dots are located or where they're located relative to each other. And that's a really important idea of position, that while the value depends on where the object is on the reference, on the number line, it doesn't actually affect what the position is. Now, the next thing I want to take a look at is displacement. Okay. So displacement is telling us about how far and what direction the object has moved between two positions. So displacement tells us about direction and distance. So let's take, for example, the displacement, which we will call delta x. Let's do that one between x when t equals 0 and x when t equals 1 second. Well, we know that figuring out the change of anything, we have to do the second value minus the first value. So for this example, when t equals 0, or I'm sorry, when t equals 1, our object is located at 3 meters. So 3 meters minus where the object is located at 0, 1 meter. And so we get a displacement of plus 2 meters. And we can represent that by drawing a line that starts at t equals 0 and ends at t equals 1. The plus sign here indicates direction, that we have moved to the right. If we complete this calculation and flipped, if instead we wanted to know what is the displacement from t equals 1 second to t equals 0 seconds, okay? Actually, let's do it for t equals 2 seconds, okay? I would do final. So let's see. I would do final which is 1 meter, minus initial, which would be now 3 meters. So I would do 1 meter minus 3 meters, and now I get negative 2 meters. And the difference there being the direction, because from 1 second to 2 seconds, now delta x points to the left. The one thing to notice is what happens if we start and stop at the same position. In other words, what if x final and x initial are equal to each other? Well, it doesn't matter what kind of motion that we are doing. If we subtract two things that are equal, then we're always going to get 0. The last thing we'll take a look at is this idea of distance. Distance, as you might be able to guess from the displacement, is we're just going to drop the direction part. Okay, so the distance between these two would be the same because we drop out the negative sign. Also, we include any part of the trip that we might take. So if I was going to find the distance when the object goes from x t equals 0 to t equals 3, well, in this part of the trip, it moves 2 meters. In this part of the trip, it moves another 2 meters, and in this part of the trip, it moves 4 meters for a total of 8 meters moved. Okay? So we want to think about, for distance traveled, everything that happens in between the beginning and the end. And the only way your distance can be 0 is if you don't move at all. All right. Thanks for watching.